Hi, it's Mr. Manzke. I am the geometry teacher. We're going to go through Unit 1, Day 2, Notes, page 1. So we're going to take a look at, first, the topic we're going to talk about today is called angles. That's our focus for today. And just the meaning of the word angle. Okay, it's Latin, Middle English. From an old French, from Latin, means corner. And the question is, where is France? Okay, that can be found in Europe. Okay, so that would be your one you would circle. So just give you a little background of where does angle come from. All right, so the first term we're going to talk about is an angle. And what is it? It's two non-collinear rays having a common endpoint. So what we're going to do is we're going to draw a picture here of an angle here. So when we draw it, okay, so it has a common endpoint. So we talked about endpoints from last time. So let's say, for example, we got a point. We're going to call it A, and I'll make it big enough so everyone can see it. There you go. All right, so let's plot our point. So we're going to plot a point here. Okay, and so there's our point A. So we're going to draw two rays, okay, and they're non-collinear. Now remember, non-collinear means they're not going to lie on the same line. So like, for example, this point here, or this first ray here, okay, we'll call that our second point. Again, points usually have the same shape, but okay, so there's point A, B. So that's a ray. It has one endpoint and one point on the ray. Now, when you draw the second ray, it's going to be non-collinear, meaning it's not going to lie on the same. So we're going to draw a second one here. So there's that. So we're going to plot a point. So I'll put a point over here. Whoops, that did not work out too well. Let's try again. So we're going to insert a point. And okay, so there's our point there. Okay, and that point there is going to be the letter, and hopefully this will work. Sometimes my computer does not want to work. There you go. All right, so if that's point C, we lost our other friends here. Let's see if we can get them back. Okay, there you go. All right, so here are the points here. Now, the vertex, okay, is the point of intersection of two or more rays or line segments. So here is our vertex. Okay, so the vertex of the angle is A. So if we go over here and we'll just make a note here, so our angle, there's a better symbol for it. We'll come back to that later. So the name of the angle would be, so if we had talked about the name, okay, so you would call this angle CAB, or you can refer it to the name, or you can go another way, you can call it BAC, or a shorthand notation is A. So in books or in somewhere, so if you talk about the name of the angle, I don't know if I can make this bigger or not. Let's see if it'll let me do it. Yeah, I guess not. Okay, so those are the three names. Okay, either you can call it BAC, CAB, or A. Now, the vertex of the angle is going to be A, or point A. Okay, and we talk about the two sides of the angle. Okay, so we talked about the two sides of the angle. So we have two of them. We're going to have the ray AB. Here, I'm just going to borrow this for a minute. And the second one is AC. All right, so it has two names. You got AB and AC. So when we talk about the side of the angle, it's one of the two rays that forms the angle. Now remember, if I reference the name of the angle, so remember the rays, so we're going to have to put a symbol on there on top of the letters. So remember the end point is A. And we got to do this one more time for AC, so there you go. All right, so we talked about three terms. We talked about angle. We talked about the vertex of an angle. Remember, the vertex of an angle is going to join the two rays together. And the sides of the angle would be AC and AB. Now, there's one other term that I wanted to talk about in our notes here. I was moving the ray there, didn't mean to do that. Let's go to the next one, which is angle bisector. All right, so if we were to, let's see if we can do this. Give a new screen here. I'm going to copy everything here. Okay, it's our last term here. So let's suppose we have an angle, and it didn't copy. All right, so let's do it. Okay, so what is an angle bisector? Okay, so when you have a ray that it has its endpoint at the vertex and that divides the angle into two congruent angles. All right, so if we take a look at, let me try one more thing here. Let's see if that'll work. Save us a few seconds here. All right. Oh, that helps. All right. So here is our angle from before. And let's put all the pieces back here. All right, so here is our angle. So let's suppose that you want to bisect something. From our last set of notes, we said that to bisect something, you're going to cut it in half. So what's going to happen is you're going to draw, it can be a line, it can be a ray. Let's try again. It can be okay, so there's our line there. I'll use a different color. Okay, so what you're doing is you're cutting the angle in half. Now, if we were to say, okay, we're cutting it in half. Okay, so what's happening is this side right here, whoops, that did not work. This is the point where, there, that's not working. Okay, so I think this is one of those points where I'm not going to be able to fully show this on the computer. I was hoping to do it, and it's not going to let me. Okay, folks, so let's just let's do what we can with this. Okay, so what's going to happen is your angle okay, is going to be cut into two parts. That looks pretty good. And what we're going to say is this top half, it's not a ray. Remember, if we're going to show that something is congruent, so like I'm going to put a tick mark here, and I'm going to put a tick mark down here. So you bisect it, it cuts it in half. Okay, so you put like some marking to show that the two angles are going to be the same. So you have two new angles, so we need another point because we're going to reference this bisector, which is the ray here. Let's see if we can do that. And we'll call it D. All right, so what happens now is that you're going to have two angles that are congruent to each other. So we can say, okay, that the two angles CAD is going to be congruent to angle DAB. So those are two. And remember, we got to insert a symbol. I don't know if we have the congruent symbol available. And yeah, we do. It is over here. And so I'll make that bigger. But remember, the two angles are now congruent to each other. And we'll make that bigger for you here. Okay, so CAD is congruent to DAB. So these two angles are congruent to each other. So again, we talked about an angle bisector. A ray has its endpoints at the vertex of the angle, and that divides the angle into two congruent angles. Okay? All right, so my name is Mr. Manzke. That was a little bit long, but I think that was okay. All right, so if you have any questions, let me know. All right, thank you. Have a good day.